Let's go ahead and upload the inertial sensor sketch to my robot, which I have plugged in on my home laptop here. So we can go ahead and just press the upload, and we get the, presuming we have the port set correctly. And remember, it says done uploading. So we can see some indications on the robot. Just remember, as you're doing this, you do need to select the right board. You need to make sure that the Pololu A-Star 32U4 is selected, and also make sure that the right COM port is selected so that you can get a connection to your robot for uploading. Now let's go ahead and see what we can learn from this. What we're going to do now is go back up here to the IDE menu, and under Tools, we're going to pull up something called the serial monitor. And the serial monitor is a separate window that displays and scrolls whatever the code tells it to display. And in this case, the sketch is telling it to display the accelerometer values. So that's what the letter A stands for, is accelerometer, and there are 3 columns of accelerometer data. And then the M stands for magnetometer, so there are 3 columns of magnetometer data and 3 columns of gyro data. The absolute maximum value that any of these columns can display is 32,767. The largest short unsigned, or the largest short integer value, but this is the column 3 here appears to be the acceleration due to gravity. That's a number generally in the range of what the sketch header said would calibrate to 1G. As we can see, it's a little bit bigger than what they said. But let's flip the robot over. So I'm going to just pick the robot up physically, and I'm going to flip it over. Notice I have to leave the cable plugged in, or else the serial monitor won't work. So all the while I'm leaving the cable plugged in, but I've just flipped the robot over so the battery pack is facing up. And let's see what that did to our number here. You might not have noticed it, but there were positive numbers before, now they're negative. Now here's something interesting. You'll notice that this is negative 15 roughly, whereas when I flipped it over, I'll just do that again to show this, that was when it settles out, it's positive 17. Now if you take the average between those, numbers, it's not quite 0. So it looks like there is some offset, and that's probably why we're getting something that looks like more than 1G in this configuration and less than 1G in this configuration. So we could probably do a little math and figure out what that offset is, and if we subtracted that out, I imagine we'd get pretty close to 1G. All right, you notice the other 2 columns are pretty small numbers. All right, that's because there's no acceleration being applied in those directions. But let's go ahead and, just for fun, let's tilt the robot on its nose. So what I've got now is I've got the blade down. All right, and let's see what happens. Now we see large numbers in the first column, large negative numbers. If I flip the robot right over, you see large positive numbers in the first column. Now the blade is pointed up. And likewise, if I tilt the robot on one side, you can see gravity showing up on that axis.